All right, so picking up on number 16, if I'm going to do, I don't want to scroll up and down, so I'll start over with how I set up my unit circle again. So remember, you only need to know really the quadrant one angles and the angles on each axis, what those coordinates are. So 225 is going to use, it's one of the 45-degree angles, right? 225 is down here. But I'm going to use the 45-degree angle that I already probably have on my paper. I would have this to begin with before the speed quiz. So the secant of 225, I start with what's the secant of 45 degrees. So flipping the x value, remember this was 1 over radical 2 before it got rationalized. So when you flip that, that's just radical 2. And then 225 is in quadrant 3. So secant and cosecant, secant and cosine are both negative in quadrant 3 because remember, all students take calculus. It's only tangent that's positive, so everything else is negative. 270 degrees is not in a quadrant, it's at the bottom of the circle. And this ordered pair is 0, -1. Cotangent is x over y. 0 over -1 is 0. 180 is not in a quadrant, it's on the left side of the circle. Sine is equal to the y value over there, which is 0. Tangent of 5 pi over 4, again, look at pi over 4, which is 45 degrees. Tangent is radical 2 over 2 divided by itself, so tangent is 1. Check your angle, you're in quadrant 3, so tangent should be positive in quadrant 3, so 1 is the answer. And finally, 300 degrees is one of the pi over 3 angles, so it's I'm going to look at it as 60 degrees first. So at 60 degrees, we already probably had this order pair written down. It's at the top of my paper. So the x coordinate there is 1/2. And then where is 300 degrees? It's in quadrant 4. So cosine is positive in quadrant 4. So I keep this positive 1/2. So we do have these quizzes set to time. That's just to get it to a place where you can do this where you're well versed at it, just like with factoring. So it just takes practice. There are practice Quizlet flashcards at the top. There's a link for that at the top of Schoology. If you're going to do that, practice drawing a portion like this. Practice drawing a portion of your unit circle. And so have some paper handy because you're not going to be doing all this in your head, like staring at the computer screen. You're going to have stuff to write down. So, okay. Last two problems. Find the distance between the 2 points marked on each circle. The angle marked is in standard position. Round to the nearest thousandth. This one is like in our notes. I meant to take this little angle marker off of here, so ignore this angle here. When 5 pi over 13 is marked in, that's less than 1/2 pi. So I just meant that to be this angle. Okay, so we want the vertical distance between A and the x-axis and the vertical distance between the x-axis and B. And because the angle, the terminal side ends at A, we're going to find the y coordinate for A, and then we'll just double it to get the distance between A and B. So the distance between A and B is equal to 2 times y. And I know from today's notes that y is equal to r, which is 7, times the sine of theta, which is 5 pi over 13. And because that's not a common angle, we'll use our calculator for that. So 2 times 7 times the sine of 5 pi over 13 is 13.090. So about 13.090. And we do need to label this. In our notes, we didn't have units, but here, if the radius is measured in centimeters, and so is that distance. For the next problem, I want the distance between C and D. Now that's a horizontal distance. So this angle 2.25, oh wait, this is not 2.25. It's 4 point, what is it for you guys? I think it's 4.10. Sorry, I had changed this at some point. Okay, so this is like 4.10, I think, I hope. If not, I'll be a little off. That angle connects here. So you're finding the XY coordinate down here. Now, when you find x, you're going to get a negative answer. So even though we want x to be a distance and we're going to double that, I'm just going to say like absolute value of 2x. I know x is going to be negative because it's in quadrant 3, but I'm just looking at it as a distance. So I'm just going to say ignore the negative and then double that answer. So technically there's an absolute value here. This is going to be 2 times 10 times cosine of, again, I think it was 4.10 radians. I might be off about that. So you get the idea. Whatever the radians is supposed to be, put that in there. And then CD is approximately equal to, so 2 times 10 cosine of 4.10, or maybe it was 4.05, I don't remember. So again, even though this is negative, I'm saying, okay, absolute value that, it's a distance. So 11.496. And that would be labeled in meters. So my answer might be off a little bit. Well, actually, let's just see what the answer key was. I have this answer key here. Oh, 4.03. Sorry. Okay, so 4.03. I can make that adjustment real quick. Second enter. Change that to 03. There we go. 12.613. 12.613 meters. 4.03. Okay, so we will see more problems like this and similar to what we've been doing on Tuesday when we come back. We'll be practicing in AP Classroom. All right, that's it for today.